Welcome back, everybody. Got the coffee, sitting in front of the car. Guess what? We got to work on the car. Well, you know, it's a big load off my mind that all the work that I did to the front of this car. That's huge. And now, remember I did all the suspension work on the car. I redid, you know, everything's pushed out, all the control arms pushed out, and all this stuff, and using different struts. Well, we got to test that. And first thing is, there's a whole bunch of things that you have to do prior to make sure the CV joints don't break under load and under certain circumstances, and we have to test that, and we have to see and make sure the CV joints won't break. Plus, we have to put in the e-brake cables. That's the only thing. Those are the two things really left underneath the car that we can't do with the car on the dolly. You know, I mean, yes, the fuel pump is one of them, but I already figured out what the fuel lines are going to be, but I need to kind of put it on the dolly so I can put them in, attach them, and then figure out exactly where the holes are going to be cut. You know, and it's really hard getting in and out of this thing with it on the lift. So that's beside the point. First thing is, let's go over to the bench and let's build some hillbilly stuff. All right, let's go. Now we're at the point of testing the suspension. We test the suspension. This is the suspension we're going to be using. This is the Cosworth early Group A stuff. This is a pretty stiff strut, you know, as in down. I mean, it's still okay. I can still push it down, but it's still fairly stiff. You know, you have to remember, it's a rally strut. Another thing is, I don't have the strut tops built for this yet. That's, you know, I just don't have them built. And because I'm not sure what exactly I'm going to use. I'm experimenting with a whole bunch of things, but I still haven't, you know, come to the final determination of what I'm going to do. Because I actually want a rubber mount on the top just to isolate the vibrations, you know, somewhat. You know, it's still going to transfer a lot, but I'm trying to minimize it as best I can. Second thing, I don't want any stresses when I take a jack and lift up the control arm. I don't want any stresses moving anything out. I want it as free movement as possible and as centered as possible. What am I going to use? This is an old 4000 strut. This strut insert is frozen in there with rust. I cannot get it out, as you can tell by the lower spring perch. I pounded on this thing and I couldn't get it out. So you know what? And also, it goes in. It's absolutely straight, and I can set everything. So I might as well build a jig off of this to replicate it. I'll just cut all this stuff off, just a couple plates, and that way it'll replicate exactly the bolt holes and center line of this strut. You know, it won't be exact as in, you know, diameter, but it'll be really, really close. And I'm shooting for the center line of the strut. I am not shooting for the diameter of the strut. So let's just move on to it. Let me show you what I'm going to use, and we can build up a rig that we can replicate this strut onto this. This is what I'm going to use for a jig. Yeah, you're probably thinking, what the? What is it? Well, this is an old bread cart, you know, from a bakery or a factory bakery. And they had all these stainless steel shells in here, and I bought these for the stainless steel shells for a project I'm doing on my house. You know, long story, but that's just what it is. Also, I'm going to use the casters are like, you know, 500 pound at each casters, and they roll beautifully. I'm going to make my new MIG welding cart out of this because it rolls so nice, and my other one rolls like such crap. You know, plus I have to fix it anyway because the new welder I got, you know, the Hobart is so much bigger than the Lincoln. But beside the point, let's start off with this. What we're going to do is, first thing, I'm going to cut the top off. I'm going to cut it right here at a 45-degree angle, right there, right there, right there, and right there, just to get this top section off. Then I'm going to cut these posts off, just put them in stock. Don't know, we'll build another car out of it. I don't know what I'm going to do with it. So let me just roll this thing down, get my bandsaw out, and we'll just chop this thing up. what we're going to make our jig out of. This is what we're going to be. This is the master, if you want to call it that. Where do we start first? Well, I kind of want to start first at making the space or width for the plates. As you can see, this is a Cosworth strut, and all they did was take a piece of metal, ridged it, and welded it onto the strut. That's all they did. And you have to remember, this is for WRC level shit, you know? I mean, jumping at 100 miles an hour, you know, and on the Unapoya stage in Finland and stuff like that. You know, that's what they were designed to do. And they thought it would hold together. And plus, they put they put a piece of pipe inside there. This is mainly just to, you know, for the impact. So it takes off. I mean, it's 2 shear points. Yes, that's great. But having this is just as a step to allow it to, you know, sit in the strut and be a part of it is great too. But the first thing we need to do is get the bolt holes in width. What it is, this right here is just a piece of stock. It looks like it's a 1x2 stock. You know, I put it in here. It's identical. So we can use this. And we do have some leeway back and forth, but it's pretty much right there. So all I have to do first is put this in here, mark it, and we will get a rough rough template of where we're going to start is with the bolt holes and the width of the actual strut housing assembly, or the strut housing tabs, if you want to call it that. Here's the jig. Well, you're probably asking yourself, why did I do it this way? Why was I measuring? All right. I didn't want to run through it and just run through it and just say, oh, I'll do this, blah, blah, blah. Okay. The main general gist is, seeing how you're probably not going to be building a strut anyway, this is just the way I do it. If I'm building myself a jig, what do I want? What's the main goal of having the strut assembly on this jig? Well, it's to have a straight line. I'm trying to make these bolt holes right here an exact relationship to the center line of the strut, not the body, you know, because what happens if we put, this is a 41 millimeter insert. What happens if we put a 50 millimeter insert and we use a bigger tubing? Well, we can still run exactly straight down the center, and we can put the bolt holes exactly where we want it to be in relation to this thing. You know, yes, this will be up and this will be up, but it'll actually be in the center. That's kind of what the whole deal is. And that's why I did it this way. Spoiler alert, that's what's going to be for the Rowdy Replica, because I'm making my own. But also, what it is as you can see, I have bushings on either side. What is that for? Well, let me pull this down. This right here will line up the back, all right? Now, on stock struts, they do not have this. What you do is you put this in here, you use a light, shine it through, and it gives you a pinpoint mark on the back. And I'll show you the way we're going to adjust it to look at that pinpoint mark. We'll just do it that way. Another thing, this bushing right here is for the threads on this. So I believe it looks like a 10 mil. And what this does, it just goes on here, keeps it centered, goes into here. Now, when we use the stock strut, right here, this is pretty much a 12 millimeter. It looks like a 12 millimeter. That looks like a 10. This is a 12. And I cut the bushing on the lathe so it's absolutely centered. So when I put this in here, it's absolutely centered, and then I'll make my ears off of that. And then with this, I'll mark where I want it to be on the end. You know, put the center point in, shine a light through, and see exactly where it is. Pretty much, you know, nothing, you know, abnormal about it. So let me start cutting this thing up, and then we will get on to making this thing be able to fit there. And then I'll show you why I have the control arms and all the CV joints unhooked anyway. There's a reason for that. We have to do a whole bunch of things, but let me just cut this up. I'll make the ears, throw them on here, blast it out, and just get it done, you know? That way we can get on to doing that, get the suspension all squared away and just done, you know? That's kind of my deal. So let me leap into action. You see that? Look, it's like I should weld it right there. There's our jig. We now have something that we can put in there and nice and easy, and it'll just go right up inside. what I got to do next. As you saw and plenty of times in the previous video, all the suspension in the front is just dangling there. I have to pull the CV joint, pull the boots off, clean up the CV joints, and light oil them so they move real freely. That's the only way we're gonna, actually see if they bind up. It's, I'm not really worried about the back because it's just one motion up and down, a little bit of toe in, toe out, whatever, just from bump steer, but that's not a problem. It's the front where you have lock-to-lock steering. You got to make sure your CV joints don't bind up and pop out. And plus, we're going to do a little modification to them to, so how we're doing it, I'll modify it. All right, let me go over there, let me pull it out, and we will get that thing out and get this thing all squared away. Now that all the CV parts are for the half shaft are relatively clean, I'm not going to pack my grease, just light oil, just so you can see them move. That's about it. One of the things I wanted to let you know is that a lot of people don't know this, and I guess just people in England know this, for rallying. But what it was back in, I believe it was the early 2000s, whenever the president, I think it was the new Fiesta came out. I think it was like 2005 maybe, something like that. But beside the point. M Sport put out a package, and I believe what they call it the Fiesta R1 package. I'm not exactly sure because it's been such a long time, but what it was that they had a package of roll cage, seats, all the gear, suspension, everything to go rally. And one of the options was to getting motorsport half shafts in there. And I talked to my friend and says, well, there must be some special lightweight half shaft that's strengthened titanium, whatever. He says no. He says they're basically half shafts that have been blueprinted, if you want to call that. What's that? Well, see this? This is the cage of a CV shaft. This is the ball bearing that goes in the CV joint. As you can see, it's like this, and you force it through. These burrs from the manufacturing process that are on this, they pretty much restrict this ball from moving back and forth. What you do is you clean up this entire section. That way they flow freely. And if they flow freely, it requires less horsepower to move the car down the road. That's the goal. So if I can, let's say if I gain 0.1% of acceleration by doing 20 minutes worth of work, you know what? I'm going to do that. My main goal is to create as least amount of stress on every single part in the car. So if there's very little stress on the CV joints, there'll be less stress on the suspension, less stress on the ball joints, less stress on control arm bushings. Everything, the less stress you have, the better, the longer your components will last, the faster you will go. I just thought I'd throw that in. I'm going to get my stuff on there. We'll clean this up. I'll put it together with just some light oil, and then we'll throw it back in the car, and we will start looking at the suspension and seeing how it works. Remember, all you're trying to find is no restrictions. That's the only thing. It's still, it butts up against it. Yeah, I found just a little bit of restriction right there. Let me clean up the rough edges around here. Also, when you do the inner CV joint, this indentation right here, this is for a gasket, so that goes to the diff. On this, you see this little ring right here? That is where it goes to the CV shaft. This is where the C-clip goes. So this mating surface goes to the CV shaft. we have the strut basically jig in place. A brand new top mount, you see there's no distortion. It's exactly in the center of the strut top. Now, I only have one bolt in this jig right here because I want to be able to move it in and out to see exactly where everything is. Also, I have these bolts right here with nuts compressing the rotor as it's actually stationary. So this is a straight up and down thing, you know. I also have this fully done, all the way inset, all tight, bolts all tight on the inner CV joint also. So I also have this is a camber gauge. What it is at full droop, you expect it to be positive camber at full droop, especially with a McPherson strut setup. Now, let me raise it up and we'll show you where the bubble goes, because the ball joint's in the center basically, and let me raise it up to basically ride height. That way we can get a good determination on what is going on. Here we have the suspension jacked up, basically equal right here, relative ride height. We're not really exactly sure, but it's going to be pretty close. What do we have? We have a 1/2 degree of negative camber right here on the rotor. The ball joint on the bottom is halfway in, halfway out, so it's right in the middle for basically being, you know, for adjustment, for fine tuning. I had to take the bolt out in order to get the negative camber. I can push it out a little bit, but this is the real problem that I'm running into. Here's the inner CV joint. This is at its full travel this way. It should be, when it's like this, it should be a lot further in, at least a centimeter in. This cage should be at least a centimeter in. Right now, this thing will not go up any further. Seeing how I never really set the beginning portion of when I did this. I never should have had the boots on. Well, it's, you know, hindsight's 20/20. What do I have to do? I have to bring the control arm in to allow more movement and flex all the way up and down, which means cutting this around. I'm almost thinking about just cutting it like this, bringing it back and welding it back in. I don't know yet, but I'm probably just going to drill a hole in, you know, to bring the control arms back in. That's pretty much what I'm going to do. Oh, isn't this a lot of fun? But we found the problem. You know, now that the alignment for camber is set, we know that this thing has to go in, so we might as well bring it in, you know. Worst comes to worst, I'll slot out everything and bring it in to where I feel it's comfortable. Then I will sit there and weld a washer on there. I don't really know yet, but you know, doesn't hurt to try. All right, let me go get the drill and we will start working on this. You know, I'm trying to get this portion of the CV joint flat with this portion. That means it should be equidistant in the center. So it looks like it has to go that much. And what's the distance? Oh, it was close. It's going to be 13 mil, which is pretty much a 1/2 inch. Now that we determine how the distance we need to push it in, also take a look at this. This is like this, and that is like that. So there's a degree. So I want to kind of lower this when I do the same thing. So how am I going to lower it? Well, I want to kind of, you know, if the ball joint's like this, I probably, let me just pull the bolts and let's bring it down and figure out exactly where we're going to put it. All right, take a look right here. See where the CV joint's all the way out? That means this is pretty much level with the outer part, not the casing, not the cage, but this center section, which is the same width as this, is equal right here. So we do have, let me just pull this down. We got a lot in, we got a lot out. So we want to make it equal. This is basically straight across. It's in the middle. That's what we're going to do. So here's a rod that I cut up from a old jack rod. And what I'm going to do is I am going to figure out where I'm going to cut. I'm going to just slice straight up slice straight down so it gives me plenty of meat to weld or re-weld in. Do the same thing on the other side, put it, and then then build something that right around it. But that's pretty much it. Or I'm going to build something that's going to be right there. We have to also make sure everything's in the middle. You can see right here. See how the angle it is and the angle right here? This is equal. So at rest, you know, sitting on its wheels all the way up, you know, as in this is just sitting like normally. This was right in the middle. So we have the most amount of up and down as we can. Why this is sitting in the middle, we have the most amount of in and out. So now that I got that, let me just start slicing this thing up, and that way I can just, I'll do the outside first, like the same thing on, you know, the outside over there first, and then I will do the, because I'm just going to take a grinder and just going to go slice it right here, slice it right there, then build into it. That's all I'm going to do. That, it'll give me enough meat to weld onto it and it'll be fine. But, well, surprises that you have to get, and remember, set up all your alignment gauges first before you before you do what I did, being a freaking dumbass. All right. Well, let me go get my mask on and grinder, and let's just do this up. Making sure strut straight up and down like that. I still have negative camber, which is great because I know I can bring it up like this. I'm going to give 2 more tacks to that, and then I'm going to release everything and see how the CV joint looks. I mean, it looks really good from here, but I got to get the tacks done first. So let me give 2 more tacks on that, and leave it there. Then we'll go through the motions and see what we got. Inside this, the inner CV joint is our most critical. You can see this is absolutely the most amount of where it's going to be out, and it's still right in there. It's really good. No binding, no nothing. It works real nice. Look at how easy it spins too. And this is full droop. And this is the most extreme case you're going to get right there. So I'm pretty happy with that. What I'm going to do, that is pretty much equal, and I wanted negative camber. So we have, what is that? Almost 3/4 of a degree negative camber, which is what I wanted at ride height, because I know I can push the strut out because it's all the way in. Pretty happy with that. CV joints look really good. All right, I'm going to give this thing a little bit more weld, and then I am going to go over to the other side, because the other thing is all I do is make plates on the other side, but this is going to be okay. Let's let me do that. I'll finish weld or secure weld what's going on right now, and then I will go over and get the other side. What I'm trying to do is to make the surfaces absolutely equal on both sides. Then I'm gonna weld right here, weld right there, you know, and get this thing squared away. Then I'll get the other side squared away, trim. Then I'll trim them up, then go do the other side. Well, looks like it stayed flat. It's welded on there good. Now I'm going to show you what I'm going to use to trim this stuff up so it doesn't look like holy hell. This is how I'm going to trim this out. I'm going to use a washer right here. It's basically the inside of here. Yeah, it's a little bit, I'm not going to go right there, but it's going to be rounded right here. And if you use a ruler to go right there, there's this line, and a ruler up here. There's this line right there. So I got to take the grinder or the cutting wheel, cut these off, do the same thing on every single side. And hopefully it actually looks cool. Then, after it's all trimmed off, I'm gonna cut everything. And hopefully it'll all be nice. Then again, it might not be. Okay, that's nice and stable. Now, let's go to the other side and get that thing squared away. Here we are on the right-hand side, same thing. About, I need to push it in about 1 centimeter. Yeah, that is what it is. But, at least I discovered it now. Let me unhook the control arms. We'll pop them down, set the ball joints, set this, and then re-weld some brackets. Well, moment of truth. Whoa. No binding. Oh, thank God. Well, there we go. I guess we have the CV joints now done on the front. And that's the only thing I'm really worried about. All right, I'm gonna tack up a little bit more here, and then we're gonna move right to the back. Well, welcome to Screw Up Central. All right, learn from me. Don't waste your time and effort until you pull the CV. You know what? It's one of those things. I hate doing CV joints because it's just so messy. It's miserable, and you get filthy and dirty and it's just not fun. And that's kind of the reason why I procrastinate until I need to get it done. It's biting me in the behind. That's what's happening. Because I put the CV shafts in because before with the boots on, I thought, oh, it's gonna be fine, and it'll all look pretty good. And, oh yeah, that's really, it's gonna be okay. Well, I put everything back in, I tightened it all up, and the CV shaft is it's way too tight. And what it is, I'm gonna have to come out at least about 3/4 of an inch, about 19 millimeters, and I'm just gonna build a hub-centric spacer. What that means is that I'm going to turn it down so it recesses into the differential, then expands back out, and so the CV joint right here will recess into it. What am I going to use? It's just some old aluminum tops that I got in a salvage yard. That's it. Nothing. It's all recyclable stuff. I also have an idea on making these things it's super hillbilly recycling, but I haven't built the tool yet to make it, so I don't really know if it'll work. I'll just leave that for next time because you know what? This is not really a priority. What's a priority is we need to get our back brakes on. The reason is, when you have your emergency brake cables set up, the only thing is you need to have the caliper set so you know where you're going to run the cables. Now, I can have, when I have the e-brake and the rotors and all that stuff all set up on this thing, what happens is that I can put this thing back on the dolly, roll into the shop, and run there. As long as I have a place where I know it's going to go, I'm just going to leave this ass end hanging off the dolly so I can get underneath there and figure out exactly where the cable is going to be. I don't even know if I'm going to use the original 5,000 cables, 4,000 cable, a Mark, a Mark III or Corrado cable, or I don't really know. I got to find out what's going to be the most efficient and work the best, because I got all those cables, kicking around, so. Okay, first thing is, I'm going to pull the hubs off. We're going to bring these things over to the bench, and I'm going to show you my, how can I put this, my best hope and coolness factor for the rear brakes. I think it's kind of cool. I like it. But hey, let's see if it even, I think it'll work, but, it's only for racing purposes only though. Not for street use. Okay? All right, let's bring it over to the bench. Now, we're over at the bench. This is our modified strut assembly, or hub assembly, I mean. What it is, it's the 4,000 Quattro hub assembly, and we just basically pressed in the rear 5,000 hub onto it. That's all we did. And you have to remember, the UR Quattros and the 4,000 hubs were outset a lot more. That's the reason why it was such a pain in the butt to do a conversion to 5 lugs on an early 4,000 Quattro, because you had to have the UR Quattro rear hub because they were outset. Now, seeing how I use the 5,000 hubs, this right here is the brake rotor that came off the 5,000. And it goes on there, it spins, but we have no room to bolt the carrier onto, because this is too, I've tried, it's just too much too tight of a clearance. And I'm sitting there going, well, I didn't want solid rotors in the back anyway. I wanted something cool. And what it is that I went and looked around. And how can I say this? What I wanted was interchangeability, and I also wanted something that, reflects the group B-ness of it, and I wanted a vented rotor. Well, let me show you my thought process I went through this. Now, I got this. This right here is a B5 S4 rear caliper. They had vented rotors in the back. And this right here is the carrier. This right here is the rotor. And it basically, well, if I didn't have that bolt in there, it'd go right on. There, just like that. And I'm looking at that going, all right, cool. Well, it works. So what I did was, nope, not even close, not even remotely close. The offset is way too much on this. It's probably better to see it like that, because it'll barely fit. But, put it on here, you got, a good half an inch to get to. So I said, okay, well, what do I have, or what would it be easy to use to get a shallow offset rotor? Well, front rotors are very shallow offset. Let me show you. This right here is an A4 rotor. And if you take a look, let me just this goes right there and doesn't hit on anything. And I'm looking at going, does this fit? Nope, it's about 2 millimeters I already measured, it's about 2 or 3 millimeters too small. And I have to grind off, but I'm sitting there going, wow, what a cool thing this would look like, because it misses everything. And I started researching going, well, I'm going to have 5,000 front brakes on this thing. So let me make sure the A4 rotor was the same as the 5,000 rotor. It wasn't. What it was is this was 276 millimeters, I believe, was what they said in the specifications for the A4, for my Avant. So and I looked at the other one, it says 280 millimeters, but they're thinner. Wow. I went and I had these in my storehouse, and that is a 5,000 rotor. right there. And it's also an Quattro, that's why I bought them. They were on closeout for like um, 10 bucks or whatever, you know, at Rock Auto. So I went and grabbed them, and I'm looking at that going, wow, and they're supposed to be thinner. So I'm looking at that going, well, it looks pretty cool to me. So I pull it out, like this. Wow, it fits. What does this do for us? It gives us ventilated rotors in the rear, looks cool. And if we had to only buy one rotor for the entire car, one rotor, you know, excuse me, one style of rotor, an Audi 5000 or an Quattro rotor. These are basically thinner than the A4 ones, but they're taller. They're 280 millimeters instead of 276. Let's see if we can. See, it's about 3 or 4 mil difference right there. Let's see. But these are a lot thicker. The A4s are a lot thicker. So how are we going to get this to fit there? Well, I went through the whole process of, all right, well, I put that there and I took this and just like, okay, there's not enough clearance. So what did I do? I took a Subaru, I had this for a Subaru in order to put winter tires on it. And I put this right here. It fits. Wow, it fits. Awesome. You know, take this, put it on there. Now with that 5 millimeter spacer, the clearance is almost exactly equal either side. I can't get much better for clearance than this. This is great. So let's, there is our rear brake setup. So let's end the video. I am, you know, you're probably wondering, say, why didn't you tell us this before? Because I didn't know. It wasn't until today when I started throwing around parts that I figured out that this is going to work. I did not know. I'm ecstatic. I am absolutely ecstatic that this B5 S4 brake setup with a 5 mil spacer and with a Quattro rotor is going to work. I mean, I am, how does the British put it, chucked, you know? I think this is a big step forward. Yeah, I got to make the spacers for the rear CV joints, but I mean, we've done a lot. The car is getting really close to actually being, you know, once I get the spacers on, put on the back, the hub-centric spacers that I got to build, and I got to build a tool to see if I can actually make them differently than the way I'm going to. I've still got to use a lathe, but, you know, I just have an idea of recycling that might be kind of cool. And that's beside the point, but I am really, really happy with this. And I think, you know, this thing was going to go back on there. I got to do I've let a whole thing slide trying to work on this car. So hopefully I can get that stuff done. And I'm not sure when the next video is going to be. Might be a little while. I got so much stuff to do, but, you know, thank you very much for showing up. Hope, you know, the thing is, you saw me screw up a bunch of times and just only waste the amount of materials, grinding bits and time and welding. Look at what I did first. The biggest thing is, and I should have done it because, is pull apart the CV joints first. That's the very first thing I should have done, you know, in order to set up the suspension. I'm going to do that on the Audi rally car. You know, when I put that up, I'm going to do everything right then and there because it's only tacked in, which it's going to be a lot easier. I just move things around. And I won't need spaces on any of that stuff. But that's beside the point. So I am so thrilled that, A, this episode is completed with what I wanted done. And I thought I was going to have to cut the strut up, but I don't have to. It bolts up. Another thing that, you know, you'd be surprised at what bolts up on your car, you know, from other pieces. So thank you very much for showing up. You know, you can do this. I'm nothing special. I'm just a hillbilly. You know, and now you have a car that has, you know, 4-wheel, you know, vented rotors, and they can all be the same. You know, you go buy 4 vented rotors for a Quattro or an early 5000 turbo, and you're good to go. And you know, I just think it's cool. So thank you very much for showing up, and I hope you have a great day. And remember, you can do it. I am nothing special. You know, just you can do it. Trust me. All right. And thanks again. Have a great day. Bye now.